We're on lesson 2 of chapter 8, which we're going to multiply polynomials. First, we're going to multiply polynomials using a table. Then we're going to use other methods to multiply polynomials. Then we're going to solve a real-world problem. Here's an example below of where we would be multiplying a polynomial. Remember, when we find an area of a two-dimensional figure, we multiply the length times the width. So in this case, we'd be multiplying the x times the 2x plus 3. Well, how do we do that? Well, one way we could do that is to kind of do that distributive property that we've worked with before. So in this case, I could distribute this x to both problems and get our answer. X times 2x would be 2x squared. X times 3 would be 3x. So then the area of this figure would be 2x squared plus 3x. So that's one way to multiply polynomials. We're actually going to learn a few more in these next few slides. First, we're going to multiply polynomials using a table. So it asks us to find the product of 2x to the third times x to the third plus 3x to the second minus 2x plus 5. A preferred method by many people is to use a table. So for example, if I have 2x to the third over here, then have all these monomials here. So x to the third plus 3x to the second, so positive 3x to the second, minus 2x, so that's negative 2x, positive 5, so plus 5 or positive 5. Then we can multiply this 2x to the third times each of these monomials. So 2x to the third times x to the third would give me 2x to the sixth. So we'd add those exponents together. This would give me 6x to the fifth. This is a negative, so it would be negative 4x to the fourth. And this would give me 10x to the third. So then this would become my polynomial. 2x to the sixth plus 6x to the fifth minus 4x to the fourth plus 10x to the third. And that's the product. So now we need to find this product. We have x minus 4 times 3x plus 2. And this one's going to look a little bit different because we have 2 in each. So we have x here. This minus 4 would turn into a negative 4. We have 3x here, and then positive 2 here. So in that case, we have x times 3x, which would be 3x squared. We have x times 2, so 2x. 3x times negative 4 now would be negative 12x. We have negative 4 times 2, which would be negative 8. Then here's where I can combine like terms, like I see here. So if I'm going to write my answer, I'll have 3x squared. I have negative 12 and positive 2, so minus 10x. And then minus 8 from that negative 8. Now we're going to use three other methods to multiply these polynomials. The first one is to do vertical multiplication. I don't like vertical multiplication very much, but I know some people who do. So we're going to teach it to you. You're going to line up your problem in a very similar way that you multiply vertically with regular numbers. So we have b squared plus 6b minus 7 times 3b minus 4. So first we can multiply everything times negative 4 here. So that'd be negative 4b squared, negative 4 times 6b, so minus 24b. Negative 7 times negative 4 is positive 28, so plus 28. Now we have 3b times b squared. That would be 3b cubed. I'm going to write that over here then. 3b times 6b is positive 18b squared. 3b times negative 7 is negative 21b. And you notice how I line them up by their exponents? That's going to make it pretty easy for me to add these then. So as I'm adding, I'll give my answer. So 3b to the third. Then I have negative 4 and positive 18, so plus 14b squared. Negative 24 and negative 21 would be minus 45b. Then I have plus 28. Now we can use horizontal multiplication. So what this means, I can write a bunch of different multiplication problems and deal with these one at a time. So if I could focus on this 2x squared, I know I'm multiplying that times the 4x minus 3. So I would write 2x squared times the 4x minus 3 Since this is a plus, I'll have a plus right here. That'll be plus 5x times 4x minus 3. And then since that's a minus, I'll have a minus here. And since this is the first power, I could just do the opposite of each one. So minus 4x plus 3. 2x squared times 4x is 8x cubed. Drop the minus down. 3 times 2x squared is 6x squared. Then we drop this plus 5x times 4x is 20x squared. Drop this minus down. 5x times 3 is 15x. Then we have minus 4x plus 3. Now we can simplify. This is the only x to the third, so we can leave it at that, 8x to the third. Here are some x to the seconds, though. So my answer, so if I have negative 6 and positive 20, that'd be plus 14x squared. Then I see these as like terms as well. So that would give me minus 19x, and then just plus 3 at the end. Now we're going to find the product using the FOIL system. The FOIL system is very similar to the horizontal. FOIL stands for front, outer, inner, and last. Front, outer, inner, and last, if you want to write that down. So basically what that would be is you got the front, you have the outer ones, or the ones on the outside, you have the inner ones, or the ones on the inside, then you multiply the last ones. Front, outer, inner, last. So as we do the front one, we have 3a times a, which is 3a squared. The outer would be 3a times negative 2, that's minus 6a. The inner, I have positive 4 times a, that'd be plus 4a. And then the last, I'd have positive 4 times negative 2, that's minus 8. I then can simplify these. So for an answer, I'd have 3a squared minus 2a minus 8. Just a word of caution on these ones. You can only use the FOIL system when there's two binomials. You can't use it for these kind of problems. So this did seem pretty easy, but it's also because there are only binomials here instead of trinomials like we had over here. But for me, this is the preferred method because it is pretty quick when you can do that. Now we'll solve a real-world problem. You are designing a rectangular skateboard park on a lot that is on the corner of a city block. The park will have a walkway along two sides, so these sides here. The dimensions of the lot and the walkway are shown on the diagram. So it asks us to write a polynomial that represents the area of the skateboard park. Well, normally to find the area of a rectangle, I would multiply the 45 times the 33, but I see that the x is missing from both. So this is actually 45 minus this x right here, and this is 33 minus this x on top. So if I was going to write my multiplication problem, I would have 45 minus x, because it's missing that x. Then I multiply that times 33 minus x, because that's missing the x. I can use the FOIL system here. We can go front, outer, inner. So 45 times 33 gives me 1485. The outer, 45 times negative x, would be minus 45x. The inner, I have negative x times 33, so minus 33x. I have negative x times negative x, which is positive x squared. So if I was going to write this in descending order, I would start with the x squared. So we have x squared. Negative 45x minus 33x gives me negative 78x. And then plus 1485. So this would be my polynomial expression to find that area. Now it asks us, what is the area of the skateboard park if the walkway is 3 feet wide? So therefore, if x was 3. So now we can plug that in and find out. So we'd have 3 squared, which would be 9, minus 78 times 3, so minus 234, plus the 1485. So if I solve all of this, that would come out to 1260. So 1260 feet squared. So this would be the dimensions of that skate park by solving this polynomial.